Okay, this is number 2 on the Target 4 worksheet. They're giving you a map saying the route for a charity fitness run is shown. Given x is the midpoint of sy, z is the midpoint of yf, xy as a segment is congruent to segment yz, and prove something else is congruent. So they're giving you a lot of information. You just have to start with one thing. So it's not always the first thing that's written, but I am going to start with this first statement. So x is the midpoint of segment sy. Okay, and when I have a midpoint, just like in the last proof, I guess I should say that's given. So when I have a midpoint, just like in the last proof, I have a couple options of what I can say with that. I can say that because I have a midpoint, I have a segment bisector, or I can say that because I have a midpoint, I have congruent segments. These are both those definitions. The arrows are going both directions in the middle because they're biconditionals. That means that the original definition can be written as a conditional whose converse is true. So that means you can write it forwards or backwards. So all that to say, because it worked well in the last time and I see a lot of congruent segments in my proof, I'm going to use this one. So because I have a midpoint, I have congruent segments. So x is the midpoint of sy. So we'll do the same thing we did in the other one. We'll highlight sy and pay attention to what are my congruent segments then. So I have sx and sy. So sx, xy are now congruent. That's my definition of midpoint. Now, I could use my second given statement that says z is the midpoint of yf, and then try to do a bunch of transitive maybe at the end. But as a tip, I find with these proofs that as soon as you can recognize that you have the transitive property, it's best to do it then, just to help your proof flow. So if I look at my statement I just wrote, I notice that I have sx is congruent to xy. And one of my givens told me that xy is congruent to something else, which means I can use the transitive. So last time what I told you was to, if you're going to use a transitive, it flows nicely if you go right underneath that and use your next statement. So now I want to use this other given statement. xy is congruent to yz. So xy as a segment is congruent to segment yz. You do need to write out reasons for everything. So that's given. So now I've used two given statements, and because of this, I can put these two together using my transitive property, since both sx and yz, since both of those are congruent to the same green box segment xy, that means now I can say that they are congruent to each other. So sx as a segment is congruent to yz. Okay, I gave you guys a couple of examples of what that's like in class. I said, if John has the same amount of money that Mr. Lehman does, and Mr. Lehman has the same amount of money in his pocket that Dr. McCarthy has, then because Dr. McCarthy and John both have the same amount of money in their pocket that Mr. Lehman does, Dr. McCarthy and John have the same amount of money. Like, you're just showing that equality through a third party. So we have Sx is congruent to Yz. That was step number 4, and that was how we used the transitive property. And I can pause here and see, like, am I done? Because on the last proof I was done. So now we know that Sx and Yz go together. So there's a third blue congruent mark. Okay, Sx, Yz, Xy. So what I'm trying to prove is that very last part, trying to prove that Zf is congruent to Sx. So I've used two of the given statements. I'm going to go ahead and use another given statement. And this is where you need to be a little bit, I guess, thoughtful of how you want to organize your thinking. Right now, I think if somebody that didn't really know what the proof was looking at it, you could follow this train of thought. You could start at number 1, go to number 2, realize number 3 is right below it, then realize number 4 is off to the right. So it follows a train of thought. Because I'm going to be starting a new given statement, I could put that right here as a number 5 because it is the next thing. And you can do that on your paper. There's nothing wrong with that. But mostly because I like to flow mine a little bit differently, and because I'm limited with my sideways space on the smartboard, I'm actually going to take my number 5 statement, my next statement, and move it somewhere else down below. I also like to use the lines on my paper going across as a train of thought. So my first train of thought was midpoint to congruent segments. My second train of thought was use another congruent segment to transitive. My third train of thought is going to be use midpoint again. So I'm actually going to start right here underneath number 3. I could start underneath number 4. That really doesn't make a difference. I could start underneath number 1. That really doesn't make a difference. But with my number 5, I'm going to say Z is the midpoint of YF. So of segment YF. And that was given. And just like last time, we're going to say that because we have a midpoint, we should have some congruent segments. So this time I'm going to use orange to highlight. And so if I highlight orange and I have Z as the midpoint, that means on either side of Z is a congruent segment. So YZ and ZF. So segment YZ is now congruent to segment ZF. That's my 6th statement I've made. My reason there is, again, the transitive property. And if we look at the number 4 right above it, which is kind of why I put number 5 where it is, I can look for the transitive property. I have a YZ, segment YZ, in statement number 4. I have a segment YZ in statement number 6. So I can put those together with the transitive property a third time and say that SX as a segment is congruent to segment ZF as a segment. That's my very last statement. Again, because of the transitive property. And that was what I was trying to prove. I was trying to show that ZF and SX were congruent.